Okay, in this video, I'm going to go over how we solve the knapsack problem using the branch and bound. This is similar to the homework problem. I guess it's in figure 12.8 on page 436 and 437. Okay, so I've picked out some random values over here. Hopefully the numbers work nicely. They may or may not. So I've got items 1 through 4 with weights here and values here. And then these get sorted by this value to weight ratio. Okay, so you're seeing which item has the most value per pound, basically. Okay, so we have a total weight for the knapsack is 10 in this case, and we're going to try to maximize the value given the weight restrictions. Okay, and we're going to at each point create this upper bound, which is the best possible answer that we can get, basically. Okay, so we do that by taking here the value, okay, of the current selection, okay, what we've picked so far, and then we get the total weight minus the weight that we have picked so far, okay, by making different choices, and we multiply that weight times the best value to weight ratio. Okay, so it's like every pound left is at the highest value per pound. So that's what we're going to fill it in at. We're probably not going to get to that maximum, but it's going to allow us to select which way to go. Okay. So we start with this, and you can do this different ways, but this Excel seems to be okay. So in our initial state, okay, we have a weight of 0 and we have a value of 0. We've picked nothing. Okay. So we can then look at the upper bound, sorry, here is going to be equal to the value, which is 0, plus the big W, which is 10, minus 0, which is 10, times what we have left, the biggest weight per value ratio, which is 6, okay, from the table there at N3, okay? So this is going to give us a UB of 60, okay? That's again the 0 plus the weight of 10 minus 0 is 10 times the best rate that we have is there. Okay, so I'm going to make this my initial condition. So let me make this do that to kind of see what we're doing here a little bit. Okay, so from this, and this they usually label that this is the 0. Okay, I'd have to make that let's see if I can center that. Yeah, that's the 0 node. Okay, and we're going to do this in a breadth first fashion. Okay, so I'm going to go in 2 directions, everywhere I can get to from here. So for each item, we're basically going to say, okay, we can have an option with item 1, okay, and we can have an option without item 1. Okay, so item 1 has a weight of 4 and a value of 25. Okay, so with that, our W is going to be equal to 4. Our V is equal to 25. Okay. Over here, we didn't change anything. So our W is still equal to 0. And our V is still equal to 0. Okay. So to calculate the UB over here, it's going to equal, okay, our V, our current V, we look at just the cell above, is equal to 4, okay, plus our big W is 10 minus, sorry, the value is 25. I get that mixed up every time. The value is 25 plus the 10, the big W minus the 4, which we have, or a 6, okay, that times the best weight to value to weight ratio that we have left. Okay, it can't be, we've already chosen 6, so it's got to be the 5, okay, times the 5. Okay, so that's going to be 6 times 5 plus 25. Okay, it's 55. Is that right? You know my arithmetic. 6 times 5 is 30. 30 plus 25 is 55. Yep. So UB is equal to 55. Okay. That's the option here. I'm going to make that there. Okay. There should be lines here, but I'm not going to do lines. Over here, we have a weight of 0 and a value of 0. So our UB then is going to be 0 plus, and then the big W minus 0 is still 10, okay, times the best weight, the best value to weight ratio we have, not including 1 because it doesn't include 1. Okay, so we have to go to the next best, which is a 5, which is going to be equal to 10 times 5, or 50. Okay, so our upper bound here is equal to 50. 50 is the best it can be. Okay, so we look at these. It's our breadth first. We do both options, and it's clear that the one that includes 1 is better. So we're going to include 1. Okay, now we're going to do the same thing. We're going to do with 2. So this is with 1 with 2. Okay, this is going to be with 1 but without 2. Okay, so 2 options there. So with 2, we're going to have with 1 and with 2. Okay, so we have the value, sorry, the weight first, it's going to be equal to the 4 of item 1 plus the 5, or 9. Okay, the value is going to be the 25 plus the 23, which is 48. Okay, that's what we have there. The upward bound of that option, okay, is going to be the value, which is 48, plus the W minus the big W, sorry, big W minus a little w, is going to be the 10 minus the 9 that we have, so just a 1. 1 times whatever we have left. Okay, it can't be a 1 or a 2, so it's going to have a 2. Okay, so 1 times 2 is 2. Okay, so that's going to give us upper bound here of 50. Okay, on this one, we didn't pick 2. Okay, so our weight is still equal to 4. Our value is equal to 25. Okay, but again, we can't use this 5 anymore like we did up here for the UB. So our UB here is going to be equal to the 4 plus, okay, that's not 4, I get the wrong every time, 25 plus the 10 minus 4, or 6, times, but now we can't do the 5, so we got to do the 2. That's a 12. That's going to get us a 37. Okay, so those are the options there. We got that with 2, and this without 2. Okay, and again, this one would have, there would be lines there and there. Okay, so again, we're going to, this is inferior. It's inferior to this one. Okay, this one is inferior to that one. Okay, so now we're down to with 3 and without 3. Okay, see what that looks like. Okay, so we're at a weight of 9. Okay, we're going to, our weight now, if we add 3, okay, is going to be the 9 we had plus the weight of this one is 7. Okay, which is 16. Okay, and this is not possible. Goes over the weight. Okay, so we have to reject it for that reason. Okay, but without the 3, our W is still equal to 9. Our V is still equal to 48. Okay, and our UB then here is going to be equal to the value here, which is 48, plus we only have 1 left. The 10 minus 9 is 1, times the 2 that we have left, okay, or 2. Okay, so this gets us a UB of 50. Okay, and since the other one is not possible, that's the one that is superior. Okay, So this is not possible. So we now look, we have this, so we know we're going to have the 1 and the 2, but not the 3 as our best options. Okay, so we have to do a, I guess we can do it right here, with 4 and without 4. Okay, the weight with 4 is going to be equal to 9 plus 6, or 15. So this is not possible. Okay. And this is the last item we have. Okay. So we know that the weight is 9. The value is equal to 48. Okay. And that's the value. Okay. The value is actually 48. Okay. Because we can't add anything else to it. That's what it is if we add the value of this one at 25 and that one at 23 gets us to the 48. Okay, so the 48 then becomes the optimal solution. Okay, so again, we started off with 0. We calculated the upper bound, sorry. This one was inferior to this one. That was the first level. Okay, so now we go with this one versus this one. So the without was inferior. We now go to this one and this one. Okay, this one's not possible. So we go with this one. Then we go with and without 4. That's not possible. So this is the optimal. Okay, so the answer here is that our knapsack would contain item 1 and item 2. Okay, so hopefully that makes a little more sense. And again, there would be, it's not easy to draw here, but there should be lines from there to there, lines from there to there, and lines from there to there, and then lines from there to there. Okay. Okay, hopefully that was helpful. If you have any questions, make sure that you let me know.